Hi class, today we're looking at Chapter 7, Lesson 5, Factoring Linear Expressions. When you are learning how to factor linear expressions, you first have to find how the greatest common factor of two monomials and how to use properties to factor linear expressions. So here are some vocabulary terms. To factor a number means to write it as a product of its factors. And again, product simply means when you are multiplying. A monomial can be factored using the same method you would use to factor a number. So whenever we are thinking of factors, they are two numbers that are multiplied together to get that answer. So the greatest common factor, also known as the GCF, of two monomials is the greatest monomial that is a factor of both. So let's take a look at a few examples. Find the GCF, or the greatest common factor, of each pair of monomials. And again, a monomial is simply a single term, and our first step is to write the prime factorization of each monomial. So again, prime numbers are numbers that are only divisible by themselves and 1. And then for 2, the step number 2, circle the common factors. So for the number 12, we factor the number 12 using prime numbers. So we can use 3 and 4, but then we realize that 3 is a prime number, but 4 is not, so we can factor it further to 2 and 2. So now the prime factorization of 12 is simply 2 times 2 times 3. Now let's do the prime factorization of 28c. So numbers that are factors of 28 are 4 and 7 is a prime number, but 4 is not, so we can factor that to 2 and 2. So now we have 2 times 2 times 7. So now we want to circle the common factors. So here are our common factors. We have the 2 and another 2. Then we have this 2 and another 2. So we have two 2's that are common factors, and 2 times 2 is 4. So that means the greatest common factor between 12 and 28 is 4. So this is known as your GCF. Then for letter B, we have 25x and 15xy. So now in this case, we know that 25 can be factored into 5 and 5. But then we notice that we also have variables. So we have the variable x. Now, for the factors of 15xy, we know that's 3 and 5. And 3 and 5 are also prime numbers. But again, we see that it has a variable of x and y. Because both the 25x has an x and the 15 has an x, that is actually one of the greatest common factors between those two numbers. So since they both have x's, then we know that's a part of the GCF. So now in this case, if I were to write it out, 5 times 5 times x, then I have 3 times 5 times x. Then I know the greatest common factors between them are 5 and x. So if I were to write the greatest common factor for part B, it would simply be 5x, because they share the 5 and the x in common. Now let's look at letter C. We have 42mn and we have 14mn. So our GCF is based on not only the numbers but also the variables. So 42, the two factors we can think of are 6 and 7. 6 can be factored to 2 and 3. So then I have 2 times 3 times 7 times m times n. Then for 14, I have 2 and 7, and that means they also are multiplied by m and n. So now let's circle the factors they have in common. They both have the 2. They both have the 7. They both have m. And they both have n. So when I multiply what they have in common, the GCF is actually 14, because 2 times 7 is 14, mn. So that is the greatest common factor between 42 and 14, mn. Then in part D, it's the same idea, except this time 36, the factor would be 6 and 6, and that could be broken down to 2 and 3, and 2 and 3 again. So 2 times 2 times 3 times 3. But then it has r to the second power. And r to the second power simply means there are 2 r's, so r times r. Now for the 72, it has prime factors of 8 and 9. Now with 8 and 9, we can factor it to 2 and 4. And then for the 9, we can factor it to 3 and 3. But we notice that with the 4, you could factor it even further, to 2 and 2. So then the prime factorization of 72r is 2 times 2 times 2 times 3 times 3 times r. So now we need to circle what they have in common. They have 1, 2 in common. They have another 2 in common. They have a 3 in common. And they have another 3 in common. And finally, they have 1 r in common. So we know that 72r also was there. So they have that in common. So they have 2 times 2 times 3 times 3 times r. So in other words, their GCF between 36r squared and 72r is 36r. And that is the greatest common factor. Go ahead and turn your notes over to the back side now. You can use the distributive property and the work backward strategy to express an algebraic expression as a product of its factors. An algebraic expression is in factored form when it is expressed as a product of its factors. So factor each expression. There are 2 methods. The first method, we are going to use models. The second method, we will use the GCF. Letter A, we have 3x plus 9. So if I were to use a model, I would know that 3x would be represented with the longer tiles, and then of course 9 would be represented with the smaller tiles. Alright, now in order to decide how to use the GCF, we do need to create a rectangular shape using the information. So knowing that 3x plus 9, that 3 is our main value, so what we're going to do is create the 3 groups and split up the constant tiles evenly. So then this would be 3 tiles for each of the groups. So therefore, this is actually representing the 3 that is factored out, that is the greatest common factor. And then up here, this is representing 1x for each section. So it would take 1 of these plus 3 of the constants. So therefore, the expression would be 3 parentheses x plus 3. Now, the same thing in method 2, I would use the GCF, meaning that I would find factors. So I'd take 3 and 9. 3 and 9, we have 3 and 1, and then 9 would be 3 and 3. So what they share in common are the 3's. So if they share only a 3 in common, then that means that is what's factored out. So that comes out, and I'm left with x plus 3. Because if I use distributive property to evaluate, 3 times x is 3x, 3 times 3 is 9. Now in part B, it's the same idea, except this time I have 4x plus 28. So I know that it would be 4 x's, so 4 is actually going to be factored out. So this is the model method. So I have 4 values that are factored out, and then I'm going to have 7 of my constant. Alright, so I know that this would equal the total of 28. I have the constants. So here, this represents the 4 sections, and then this represents x plus 1, 2, 3, 4, 5, 6, and it should be 7. So it should have 7 constant tiles on that. So therefore, my answer is 4 parentheses x plus 7. Now for the GCF, I would use the factoring method, factor it out, and then 28 would be 4 and 7. And again, they only share the 2's in common. So that means they share a total of 4. So 4 could be factored out, and then you're left with x plus 7. Because 2 times 2 equals 4, so that's the greatest common factor. So that is what gets factored out. Now in example 3, the Reyes family has saved $480 on a down payment for a new television. If x is the monthly payment for 1 year, the expression 12x plus $480 represents the total cost of the television. Factor this expression. So now in this case, we have 12x plus 480. So I can think about what factors go into both 480 and 12. And it just so happens that 12 we can factor down to 2 and 6, then 2 and 3. So 2 times 2 times 3. And then for 480, we can factor it down to 48 and 10. And that gives you 2 and 5. And then this would be 6 and 8. And we'd have 2 and 3 and 2 and 4. And of course, that'd factor down to 2 and 2. So now what they share in common, they share a 2 in common. They share another 2 in common, and they share a 3 in common. So they share all those values together, 2 times 2 times 3, and that is a total of 12, meaning that 12 can be factored out, and it leaves you with x plus, and 480 divided by 12, we're left with 40. So then when I factor the expression, 12 parentheses x plus 40 would be our final result. Now go ahead and take a few minutes to practice the factoring of each expression. If the expression cannot be factored, write cannot be factored. So if there is no number that both values have a GCF in common, then you cannot factor it. Use algebra tiles if you need them, but it is not necessary. Just make sure you look at the greatest common factor. And again, if you cannot, then you just write cannot be factored.